The next security track meeting. We're going to be talking about firmware updates and recovery, which we are merging into one doc. And Eric Spada from Broadcom is here to talk about it.
Great, thanks, Nate. So this talk, as Nate discussed, we have two documents that are half written in OCP today, and both of which in the security group, both of which, one of which is the firmware update requirements, and the other one is a recovery documentation. And Nate and others in the security group decided that we should probably put these into the same document since they have a lot of the same aspects of it. So the first part of this, we'll go over kind of some of the generic requirements around firmware update and what we want to kind of stress as requirements from firmware updates. And also we'll discuss, at least my thoughts on how much of this, there's a ton of different specs on this, and how much of this do we want to do, and how much do we want to actually push off and point at other specs. Then the other piece is recovery, and the recovery is kind of split into two pieces. One of which is where you still have a device that is securely has a secure identity, and one of which doesn't. And the one that doesn't, that's what we're calling repaving, and we go in and essentially reset the device to a various state, to a known state. The last, I just threw a couple of pieces in here. There's a couple of different topics that we've discussed in the OCP calls about debug, test, / non-production images. I have some thoughts on that, and maybe we have a discussion on how they're handled. And then we've also had some discussion on dual signing, and dual signing in this context is essentially a manufacturer authorization for authentic firmware. And then the second part of the signing is where a provisioner or a provider of some type chooses which types of images can be, which types of approved images can be loaded on the system. So it requires a two-step signing process. So that's the flow of the talk. All right, so why don't we start with firmware update? So one of the things, and we've had a couple of discussions kind of this morning in some of the other security track pieces about firmware update and lifecycle management. NIST has a very good set of standards on this. It's a SP standard. It's in the link is in the references. There are some issues with it that have been identified from an at-scale deployment. So if you look at it, it's all around three particular models around being able to detect, protect, detect, and recover. The recovery piece of the NIST spec is pretty, I would say, oriented towards a physical presence model where someone comes up, touches the machinery in order to be able to do a recovery. So at scale, from a cloud provider perspective, this is less than desirable. We've been told by our customers numerous times that they never want to go touch hardware, which is good. And there was actually there's actually a document from the CSA, which kind of brings back some other pieces that gives some guidance as to how to modify the NIST standards or to augment the NIST standard in order to be able to do the update. And what they go through is they basically say that there needs to be an automated recovery process. Now, they don't go into a lot of detail on what that is, which is good. This set of specifications will go through, okay, from a best practices perspective, how do we want to be able to do this update? The other pieces they talk about is if you look at the NIST specifications, they kind of have this concept of a known good image. That's kind of an issue unless it's kind of a dedicated recovery, because if what can happen is that if there are security vulnerabilities in that old known good image, once you roll back to that image, those security vulnerabilities are then open. So really what the best practices that we want to be able to talk about is being able to do A/B banking. And what that means is you have a version A and version B of the software, which is hopefully maybe only a few revisions old, and a mechanism to validate and put A or B in and use that as a recovery. And then the final piece is that if that fails and there are a couple of issues that we can talk about how that would fail. We can talk about flash corruption, issues with the devices. All these things can cause essentially things to fail when they update. We need to kind of define an automated recovery process that will go through and automate how we do the recovery. So the other thing is that if you look at firmware update, there are a ton of standards out there. If you look at the DMTF, which is the management form, there's the platform level data model that has the ability to kind of define how to do an update. That's what many of our many components within a server would use. If you look at our NIC products, PLDM is one of the pieces that we use. Also, if you look at from the UEFI infrastructure, there's secure capsules, and secure capsules are used essentially to update firmware and devices and firmware and other components of the system. And there's a ton of others that are here. So my view on this part of the documentation is we want to be able to define the high-level standards that you need to meet. We want to take the concepts of those standards, right-size them into what our environments need to be, and then point at example documentation on our example implementations of how we do this. Kind of like what we've done with the attestation document, because the attestation document, we go through and we say, okay, you need to do attestation. These are requirements. Oh, by the way, SPDM and Cerberus are examples of this. So I'm thinking that's kind of the way that we want to be able to do this. Is there any kind of comments on this, Nate or Lane? That seem reasonable? Okay. Excellent. All right. So again, I think what I'd like to understand is and we can put this, I'll put some of this in our spec, is other than these two, I'd like to come up with a list of what other ones are out there that we want to use as templates. I think that's a key thing that we want to look about. I think both of the PLDM and the secure capsules with some tweaks would allow us to do what I think we need to do. But I don't want to preclude other pieces as long as they meet a base set of requirements. All right, thinking about anything else on this. All right, so I think from a firmware update perspective, the other thing that we talk about in the attestation spec is the authorization on how to update it. And we have an authorization, actually an authorization key. So that needs to be called out in this document as well. So it is to be compliant with the attestation spec around who is allowed to actually update the firmware. And it's specifically a different role than the secure boot root of trust. So there's a role that goes in and says, okay, you can update firmware, and there's a role once that firmware is updated, it then is in the device ROT's capabilities. So that allows you to do a couple different things, and the dual signing piece is different than this, that we'll have to kind of discuss at a high level. All right, so the recovery room paving.
So we had
sure.
an incoming question.
Sure.
Which is do you think that most of the standards and specifications for the secure update of firmware also apply to the in-field update of fuses?
So if you look at so I'll tell you my view. If you look at the NIST specifications, they definitely tell you about, they specify two or three separate pieces of information. One is the firmware, one is what they call critical parameters, and the last one is, I think, parameters. So clearly to me, the critical parameters would be part of this update. And we could discuss whether we want all the parameters there, but I think as a baseline, for sure, as part of the security envelope, the critical parameters need to be part of this update process. And there has been some discussion on the weekly calls about, the configuration, what is the signing key for that, and how is that signed? But that's my view on it. Nate, what do you think?
So I think they're asking specifically about fuses. I assume they mean like one-time programmable fuses in the field, which need a higher level of sort of protection since you can't go back and fix them later. So I think what we really need to get to in the question is whether or not sort of the standard specification is also good enough for fuses, or do we need an additional specification that's specific to fuses, since you can't go back and fix it if someone is able to get into them.
Yeah, I like to use the example of the anti-rollback counters are probably the easiest.
Need to get to in the question is whether or not sort of the standard.
Sorry about that. So the one that I like to think about is the anti-rollback counters. That's probably the easiest and most concrete example of something that's typically implemented either in a fuse or some type of update that you can't go backwards on. And there's been some discussions on this. The question is that, that one in particular has some implications particularly on AB banking. If you have A and counter B or if you have the counter at A for A and it's incremented for B, and then you can't recover back to A because your anti-rollback counter is now scromped. So the question is that do we want to define a process by which you move the count, you then in some kind of temporary fashion, and then finalize the count after you've understood that the update is successful? This is a pretty good discussion we should have on exactly how to do some of these things that have non-revertive properties in the hardware, and fuses is one of them. What the heck just happened here? Can anyone still hear me or no?
Yep, we can still hear you.
Sorry, something just the login just became successful on that on the FN thing, so that just kicked me out. Sorry about that. Okay, so is that enough? So we should make this as definitely a work item to understand how to update those counters and what the right procedure is. Do we want to have special set of APIs on that, or can we just use the standard update? Is there any other questions that have come through?
Not at this time.
Okay, perfect. Excellent. All right, so now let's talk about recovery and I think something called repaving. I'm not sure this is an industry term, but I'll define it here to make sure that everyone's on the same page. So the recovery process is that I have a device, and I'll talk about this kind of device centric and scales to bigger constructions, but let's just talk about a device first. So a device has some issue that it can't boot an operational firmware image. However, the device still has the provisioned identity to it. It still has the connectivity to the system. It just doesn't have the production image. So an example of this is what I just talked about, is that there was some mistake or some failure in the way the anti-rollback counters were updated. So in this case, there's an image there. It just can't be booted because it's too old. So the question is how do you bring the device back up into compliance? So in that case, we're calling that recovery. We still can authenticate the device. We can still attest the device, And we're going to define a minimal set of requirements in order for that recovery image to be able to download and install a proper image in order to be able to get back to a compliant situation. But so the big piece with this is that this minimal MTCP is still secure booted. It still can deal with the attestation protocol that's provided in the server, whether it's Suberus or DMT or SPDM. It's still a full full citizen, so to speak, within the infrastructure. However, it just can't load an operational image for whatever reason. So that's kind of the first situation. And then the second situation is that where the device is still there, all of the information about the device has been destroyed. So there's, so effectively in this case, for people that use DICE to hold certificate chains or whatever, this case, the entire flash is corrupted, and the device boots. However, it can't find an operational image, and it even can't find this recovery image in order to. So what we're defining in this process is being able to repave the device, and repaving in this case would not only update that would allow you to download a recovery image and essentially do the same process, but also may, depending upon the parameters of the system, it may allow you to reinitialize the identity of the device within the attestation infrastructure. And there's been a bunch of discussion on this within the OCP security group on exactly how to do this and what are the requirements around this. And I think it would depend a lot of times on what the security aspects of the system are. And we've talked about this. And the other key aspect of repaving is the repaving piece is that we're defining a minimal set of SM bus primitives that are friendly to implement in a ROM. So the thought process is that a device that has this capability and this minimal set of infrastructure can boot into ROM, and the ROM will allow you to essentially, through a very defined process, push down the recovery image and then reset the device. The recovery image will then become active. The recovery image will then recover the rest of the device. So that's kind of the bootstrapping that we're thinking about. The initial thinking about this was that the recovery image could be the repaving image, but given the discussion in some of the calls and the advice of some of the device implementers, MTCP stack and ROM is at this point is a pretty big ask. So we're trying to come up with something that's very, very simple and easy to implement in ROM and mostly and easy to test as well. So from a recovery piece, that's kind of these two separate terms. Then the next question is that what is the policy by which repaving and recovery can be initiated? Had a bunch of discussions on this. Obviously, the first piece is that the device can decide to go into recovery mode. This one's probably the most straightforward. If the device boots and it can't find an A image or a B image that authenticates, it would then try to boot its recovery image, and then it would signal via a specific command that, oh, by the way, I'm in recovery, so you need to recover me. So that one's probably straightforward. The repaving also can be also detected by the device. So entering repaving by the device is can be straightforward. Where the big complication is external entities. The management controller, BMC or whatever says, I want you to recover, or I want you to enter recover or repaving. This is where things become more challenging. The most obvious piece is that this could be a denial of service attack, where the BMC or other components come in, they basically tell you a recovery, and recovery almost certainly is a service affecting event in that it has a recovery image. So for a NIC or even a disk drive or anything else, it's very unlikely that the device will still be operational in this state. So this is almost certainly a service impacting event. So the question is that how do you, what is the policy that you put in as to how do you enter this repaving or recovery state? And I think where we've left it, and there's been some discussion on whether this is the right decision, is that only the device can enter recovery or repaving. We're not going to allow the BMC to come in and do this. Now, there's been a bunch of discussion of whether this is the right decision or not, but I think that's where we are from the baseline. And anyone that's on the call that wants to provide input to that, we definitely would like to hear your thoughts. Let's see here. What else do we want to say about this? I think the other piece of this for both repays and recovery that I didn't say that I want to make sure is clear is we're not defining another set of keys. So both of these recovery and repaving image will be signed with the device's ROT keys, the secure boot keys that we're going to talk about in later sessions today. So it's not like there's a separate set of keys that we're going to use for the recovery image or for repaving. So all it is that and this was kind of by design to be able to make sure that, from a security perspective, particularly when you're talking about ROM booting, you want to reduce the number of options. So in this case, it's exactly the same set of keys. It's exactly the same infrastructure as you would boot normal firmware. It's just the version of the firmware is different. Is what we're thinking.
I have a question. This is Eagle.
Sure. Yes. Absolutely.
Hey. So first of all, I agree with you about the don't let the BMC repave because it's a threat. I think we've discussed it in the past. But on the policy question, we've been talking about the case where some operators don't want recovery to happen. Do you think we need a policy that says, hey, even if A is not properly signed, boot it and just signals that you're booted unhealthy, or is that a risky thing to do? What's your thoughts on that?
So there's a couple of ways to do this, this kind of is loosely connected with kind of debug images. So I think the point is that at scale, probably the worst thing that can happen is the device doesn't boot. If the device doesn't boot, you really can't do anything, right? So what you need to do is either anything that we do here needs to be able to be automated, such that okay, the device doesn't boot, it's in recovery, I do X, it's in repaving, I do Y, and then recovery. If it's in none of these two states, it's RMA, it's out of piece. So I would think from my perspective, I think probably what the right piece to do is to define a set of primitives, policies around recovery, repaving. And I think there's probably enough interest from the people I've spoken with about being able to force repaving from the BMC. I would think those three policy flags are probably what we want to define in this. And if you're super called paranoid, you can basically prevent all three of them from happening, or you can choose which of these policies. Because I do think that there are definitely customers that want to boot this thing up and they want to be able to do all of the, they want to deal with this via attestation. So if we come up and we boot an image that's not properly signed, it boots, and you test it, and the attestation is going to fail, hopefully, we would assume. So then the question is that then there's an automated set of remediation to do that. And I think that's probably what some of the cloud operators are looking for, is they always want it to boot, and they want it to boot it in a way that the attestation is clearly fails. And then they want to be able to do this. So did that answer the question?
Yeah, and I agree. And I think the connection to attestation is a good point
Right.
here.
Correct. I think we need to make sure, and this was one of the pieces we've talked about in the past, is that we need to make sure that this recovery state, the repaving state, or any kind of pieces of this is clearly in the attestation quote. And in fact, I think what we want to make sure is that if I take an operational image and I boot it as part of recovery, that it's going to attest differently because it's in a different state. It's not in the operational state, it's in the recovery state. So I think that needs to be clear in this specification. And Elaine, do you agree with that?
Yeah, we have to be able to detect it for sure. Otherwise, you
Yes.
wouldn't know.
Right.
Yeah. The one thing that I've learned through even the most recent comments on the spec from Google is that their recovery mechanism isn't even a BMC, right? It's yet something else.
Right.
So yeah, it's almost like, how do you specify what the device can do and what are the policies of the administrator? You know, it's yours is more complicated. You have the hardest job.
I think it comes down to a couple of clear set of policies, and I think the three that we talked about is probably it. There may be a couple others, but I think the critical thing that we need to make sure is that the secure, and if you read the specs from DICE and others, they kind of gloss this over, but that the state of the device needs to be included in the attestation quote. So again, if you take the exact same image and the device is in recovery, that image is going to attest. It's going to have a different attestation signature than if you took that exact same image and booted it operationally. And I think that's a key thing that is kind of glossed over in many of the specs and needs to be 100% clear here, is that depending upon these three states, you're going to get different attestation. And I think that, yeah.
One variation on that, which is in some cases, vendors want the identity to change when it's in a different state. And I don't know that I personally agree about that, but that's yet another variation on a theme.
I have seen that, and I'm not a fan of that either, to be honest. I've heard that in the past where you have kind of a debug identity, but I would rather have a single identity and different paths to an attestation than different identities, because you have to manage the identities at the end of the day. If this device gives you a debug identity, how do you have any kind of parlance of that, where that came from? If it's rooted in a device root of trust as part of identity that's been, onboarded or enrolled in some type of process, okay, yes, I know this device. It has a valid set of device certificates, but it's just not healthy from a firmware or from a state perspective. I think that's inherently easier to manage than this device suddenly shows up as a different device. So that would be my view on this.
There were a couple of questions in the
sure.
chat. If you want to take a look.
Yeah, let me see if I can get them to come up with that. Okay.
They're copied into the Zoom chat too.
Okay. All right. So why don't we start with recovery and repaving? Okay. So I'll go over this one more time, maybe slowly, for people that haven't lived it like we have. Okay. So, so the easiest thing to think about is from a recovery process. If the device is in recovery, what it means is that the spec that we're working on defines a very minimal set of NTCP commands that allow you to go through an SPDM attestation and a PLDM firmware update. So a device in recovery still will attest properly. And what that means is that it'll have an attestation signature, and that signature will be signed by the device's identity. So that's the device. So, and the easiest way of thinking about this is the device essentially is I move my anti-replay counter up, and for some reason, both A and B images don't pass the anti-replay check. So, so then the device detects this and it goes to recovery. Now, the recovery image is still valid. The device is in good shape, but it just can't find an image that it can, an operational image that it can load. So this recovery mechanism will allow the ability to push that recovery image into the device and bring it back and bring the attestation, bring it up to attestation. So that's recovery. Repaving is that minimal recovery agent is not available. And the easiest way to think about this is that not only did I corrupt the A and B, that the entire flash has been corrupted. So in this case, my A, B image and recovery image are all scrunked for whatever reason. And let's assume that this device uses something like DICE, where the device certificates are actually stored, are authenticated and stored in non-volatile flash. Let's assume that that's been corrupted as well. So now this device only has essentially a self-signed set of certificates and has no storage. So at that point, you can go through and how do you bring this back into compliance? That's kind of the thing so that's the discussion on these on the repaving. So the repaving would go down and install an identity, and there's a way to do that with DICE and some others. And once that identity is installed, it then would install the minimal recovery image, and then at that point, the device would be in recovery mode. And there's a bunch of security implications to this. And depending upon on how things are deployed, there are questions about how this is actually done. Okay, so that's one. So the other one is can we consider a device quarantine, i.e. suspect of our hardware failure or security attack? So I think the question here is asking is that when a device is in recovery, what is the system, how does the system view that device? We haven't talked about this a lot, but from my perspective, this device is still, the security envelope, this device has not been compromised. Or let's put it this way, we do not know that the device has been compromised. If I'm in recovery, I have a properly signed set of images that we're running, and the identity of the device is intact, and it can basically implement the attestation protocol, either SPDM or Cerberus. So this is a device that just basically doesn't have an image, an operational image that can be done. So from my perspective, we do not know if this has been compromised, or the operation. If the reason we got to this state is because the A or B images have been compromised, but we still know that the device is intact. In repaving, there's less security, there's less capabilities that we can attest in this state. If the identity configuration is lost, then you're relying on the self-signed certificates or the manufacturer certificates that are in the device, and they have to be obviously ROM or built from ROM. So this is so depending upon the supply chain management and the onboarding / provisioning process, there may be additional steps that need to be done in order to get this into compliance. All right, let me see here. All right, so that's the next one, recovery. Okay, all right, so let's see here. So the other one we've talked about here is BMC doing recovery. Okay, hold on a second, I'm coming back.
I think that question is to explain why a BMC cannot trigger recovery.
Right. So I think we discussed this, but let me give a little bit more detail. So the biggest issue, so the question comes down to whether whether the BMC is a trusted entity. From a security perspective, we basically say the BMC is untrusted. Now, the PA root of trust can be implemented inside the BMC, but it's not inside the BMC proper. So I think from our security perspective, we're assuming that the BMC is untrusted. So if you agree with that, if you would agree with that statement, then the BMC could effectively come in and force you either into, if you allowed forced recovery or forced repaving, what this would do is cause, like something like a NIC card or a disk drive, it would cause a service affecting event, almost certainly, if you allowed this. What this would mean is I want you to reset the card or reset the device, and I want you to boot the recovery image. So clearly that would cause an impact to service. So, that kind of is a definition of denial of service. So there are certainly systems where that's not good, or that's certainly not a desired behavior. So I think that's why there needs to be policy in whether this is allowed or not. Now, other system designs, the BMC is kind of off in its own island, and it's its own separate entity, and it is inherently trusted. So in that cases, in order to be more resilient to these type of failures, you may want to allow coming in and forcing recovery or forcing repaving. And I think with a simple set of policies that we can allow all three of these use cases, whether you trust it, you don't, or others.
So another thing is like having the BMC come in and force recovery is not significantly different than just pushing an update. So you can view that as just part of update instead of recovery if you need a new image there.
Correct. Right. I think the big picture is both recovery and repaving should be the exceptions. Right. So the assumption for both of these is that there are issues with the underlying firmware infrastructure. If the BMC wants to be able to come in and push an update, Nate, just as you said, they should just be able to push an update through the normal infrastructure, and that should happen. So there shouldn't be any real difference between the recovery agent on the BMC, or just that talks to this recovery, or the operational image should be identical from a protocol perspective. That's kind of the design of this. All right, so there's a question on in-field update. So I think from our perspective, in-field update we don't make much of a distinction between in-field update and let me just read this. Okay, also, sorry, we already got this one. Sorry, that's the one with the, all right, so the last one is systems like servers or switches will converge on acceptable TCP firmware configuration, acceptable, different for different tasks. Okay, yep, I agree with all of this. All right, so I think this is very true. Again, I think the key thing is that for each of these workloads, the attestation has to be different. That to me, the big piece is attestation is the key to figuring out whether the state of the device matches the expectation of the user. So if you want to be able to boot a repair or a more permissive image, that's fine. It has to be properly signed. And there can't be any backdoors for that. And it has to attest differently, such that when the attestation protocol comes in, it gets a signature, and then it can determine okay, this device is supposed to be in either recovery or it's supposed to be in this different workload. It's supposed to have this attestation spec, this attestation quote. That's the critical aspect of this from my perspective. Do you see anything else in here, Nate, that I'm missing? Did I answer all of them?
No, you got everything so far.
Okay, all right, excellent. All right, so next one. All right, so we talked about this. Is there anything else we want to talk about here on recovery, on repaving? We talked about the policy. I think those 3 policies are probably the easiest thing to think about. We may have some others, but I think that's the big thing. And again, the 2, I'll say it again, just to be, is that has to test different and it uses the same root of trust keys. We don't want to invent a new root of trust. All right, so why don't we move on to the next? There's a couple of miscellaneous things that were on our piece, and we kind of talked about this a little bit because it kind of, so there's been some discussion about debug, test, or other workflow images. And again, I don't think they should be different keys. That's an opinion. But I think we all agree that they must, again, attest differently. So, so from a firmware perspective, vendors typically or sometimes want to be able to have debug images or test images, either for whatever types of reasons. But I think those types of images should be signed in exactly the same way, and we should use attestation to turn to look at this. So again, that same image that's declared a debug image or a test image should attest differently than if it's loaded as a production image, is my opinion on this. If anyone has opinions on this, we should just let us know.
I was gonna say, I agree with your opinion, Eric, especially, or one thing that we definitely don't want is for a device to have some like extra keys hidden away inside of it that are the manufacturer debug keys that the customer doesn't know about. And so if everything gets signed and attested in the same way, you don't have to worry about extra keys laying around. You just have to have your root of trust say, oh, it's a debug image. That's fine. I'm back at the manufacturer.
So a question is that, do you want to, should we have policy that would prevent debug or test images? Or would that all be done through attestation, do you think?
I think you can do all that through attestation.
I do too.
The image shows up with a different attestation key, it's just not allowed.
Okay, all right. So I agree with that. I think there's been some discussions about that, but I think the attestation signature is the easiest way to do that. And again, we have to make sure, and we've done a bunch of work on the attestation spec to make sure that's there. The state of the device has to be, security state has to be in the quote. So as long as we kind of make sure that that's clear, and then this is the, I think this is a good way to go. And I don't think we need specific being able to turn it on or off. You can just basically say, from an attestation perspective, this doesn't attest and it's not allowed in the system. We had a big discussion about dual signing, and this was kind of in the Google Doc that we've been using. So, and there was a whole presentation, I think it was from Intel, but I don't want to blame anybody, that basically had authorized firmware. And from my perspective, the manufacturer would say, this is kind of the list of firmware that you can run on the device. And the operator would decide which of these are permitted. So the question that I have for this, and maybe Yigal, you can help me with this, is this part of do you think this is part of the firmware update process? How does this fit with the rest of these topics?
Were you asking me?
Yeah, sure. Why not? since you were in charge of the big doc, I'll blame you.
Yeah, Yeah, okay. So Alberto and I are doing a talk tomorrow about owners and updaters and who is authorized to do what, and I think that would be a great topic to dive into. There, I definitely agree with you that there is some, like there are two roles here, right?
Mhm.
And we need to decide who is authorized to change what on the device. And in my mind, this is tied to dual signing. I think Alberto has a slightly different perspective. So tomorrow we'll see what we get to. So that's the session for 8 a.m. tomorrow.
Excellent. I will be there.
I definitely agree with you that there is some, like there are two roles here, right?
Mhm.
And we need to decide who is authorized. Wise?
Oops, is that me? I don't think so.
I think it was replaying what I just said. Strange.
So I think if you're on the web portal and on the Zoom, there's some delay.
All right, so we're out of time with this.
Okay, excellent.
There were a couple of questions in the
Sure.
chat in FN Virtual, so we can respond directly